In this example, we want to convert the following Cartesian equations, i.e. rectangular, to polar form by hand, showing all work, and draw the corresponding polar curve. All right, so it doesn't hurt to remind ourselves that x is equal to r cosine theta, y is equal to r sine theta, x squared plus y squared is equal to r squared, and the tangent of theta is equal to y divided by x, right, from our previous page. So we can use these pieces right here. So x is equal to r cosine theta, y is equal to r sine theta. Now we could just hop right to here, but I want to show you that this will work out and kind of derive this formula as I go. So if x is r cosine theta, then I can say x squared is r cosine of theta squared plus, if y is r sine of theta squared, and that's equal to 25. This is r squared cosine squared theta plus r squared sine squared of theta. Now you'll notice both terms have an r squared in them. So I can take r squared out and I'm left with cosine squared plus sine squared. But of course, that's 1 by the Pythagorean identity, which means r squared is equal to 25. Now I knew that anyway because x squared plus y squared, which is what I was given, is r squared. But I wanted to prove that even if you forget that piece, you can still derive it. So that means that r is equal to 5. Now r is equal to 5 is a polar curve that's a circle. Its radius is 5, and it has a center at the pole. In other words, it's this circle. Let's see if I can draw it. Even with rings, it's not always easy to draw a circle. There we go, more or less. Remember that a polar curve will be equal to r is equal to some function of theta, with the only exception to that is theta is equal to a constant, right, which would be a diagonal line that goes through the pole. So when we're looking for a polar curve, we're looking something in that form. All right, so that's easy. So we've got a circle of radius 5 with the center at the pole, which is what r equals 5 is. All right, now for this one, this won't be as simple as that one. That one is really easy. All right, so, well, we just saw up above, but this is r squared. I proved it up above, but we actually knew that anyway. X squared plus y squared is r squared. So this is r squared is equal to 6, and then y is equal to r sine theta. Okay, well, there's an r on both sides, so I'm going to divide by r because I feel like it. And that would get me r is equal to 6 sine theta. Okay, so that's a function of theta. So I have a polar curve. It's right here. All right, so let me draw that polar curve with Desmos. Oh, and if you wanted to see part A, there, see, it's a circle. Radius 5, no problem. All right, so let's go to the next one. Ah, it's a circle as well. But it's a circle that is not centered at the origin. It's a circle that's centered at 0, 3, right? And then goes around it. So let me draw that on my paper. When you're drawing on your paper, of course, you're going to want to try to draw points that you can kind of see on the grid. So for example, there's one over here at pi over 4. Now technically it's 3, 3 on the XY grid, which Desmos is showing, but it's pi over 4 and out about 4 and a little bit of change from the rings. So I would put that on my graph. Actually, I'm going to see if I can put them side by side. Maybe that'll help. Okay, so let's see here. So 0 at pi over 4, this guy right here, I'm going to be out just past the 4 ring at pi over 4. So right there. And let's see, at pi over 6, it looks like it's exactly at the 3 ring. So pi over 6 right at the 3 ring. And then 7 pi over 6 is probably the same, or excuse me, 5 pi over 6 is probably the same way. Yeah, at 5 pi over 6, that radial line, it's right at 3. So I'm going to go out 3, 5 pi over 6, and then out this pi over 4 will go out like that. And then let's see what else we got. 2 pi over 3 and pi over 3, it looks like it's just past the 5 ring. So this radial line, I'm going to go out past 5, just a touch, and out past 5. See, that's 4, 4.5, 5. So it's just past 5 on the 2 pi over 3 ring. And then I'm going to try to connect them together. Hold on. I can draw better this way because I'm right-handed. So I'm going to turn my paper around. There we go. I'm not a computer, so I can't draw it as nicely, but there you have it. So what is that? That's a circle. It has a center. Now the center is, if you're looking at the XY coordinates, it's 0, 3, right, over 0, up 3, right here. If you're looking at the R theta coordinates, it would be on the 3 ring, right, because it's the 3rd ring, and it's pi over 2, right, because this is the pi over 2 angle, so on the 3 ring. So whichever way you want to say it. So if you want to say it in XY coordinates, it's that. If you want to say in R theta coordinates, it's that. And the radius of that circle is obviously 3.